Hey, I just have a few problems that I want to show you some calculator functions, how to actually get your calculator to do what you want. First off, I've got this function f of x equals, and then this is a cubic function because I've got x multiplied together, got x times parentheses x plus 2, and parentheses, new parentheses, x minus 3, and then g of x is going to be x minus 3. So I want to figure out some things like f of 4. Now, we know that we could just plug in 4 into those 3 spots for x's and multiply it all out and work it and get a number. We also know we could find zeros by setting every factor equal to 0 and then solving for x. We'd have 0, -2, and +3. Okay. The minimum, though, ends up being a little bit more difficult. We could use some calculus to find that if we wanted to. And if you are doing a calculus problem, you do actually have to show calculus work to find a minimum. But if you're doing something like the ACT or a multiple choice question, your calculator can help you find a minimum. Okay, other things that are important, points of intersection. Finding intersection points can help you solve systems of equations very quickly, which is lovely. Okay, so I'm going to start off by clicking the y equals button. I have already typed in both of those equations. I've typed in the top one as the f of x equation and the bottom one as the g of x equation. Okay, I am going to, on my page, note that this is y1 and this is y2, so that later on I can use my variables in my calculator to use y1, and that will just type in this equation for me, or y2, and it will type in this x minus 3 for me, so I don't have to do that work. Okay, so let's start by only looking at the first equation, f of x. I currently have both of them showing up because both of those little equal signs have little black around them. So I'm going to go down to my second one, which I don't want to see, and I hit left to be on top of the equal sign. Okay, I will hit enter one time, and then you can see if you move to the right that that one is no longer highlighted. So when I click graph on the top right, the only graph that's going to show up is that cubic graph, not also the g of x linear graph. So this guy should look something like this, and then this guy should look like that. Okay, we don't see this one yet, just that one. Okay, we can see by counting that our graph crosses the x-axis at -2, 0, and 3, which we did expect. Zeros are at -2, 0, and 3, because those numbers plugged in make those little factors equal 0. We could use our calculator to help us figure out what those numbers actually are. Okay, finding something like f of 4 or f of 1.4, there's a couple of different ways that you could go about finding what that y value is in your calculator. This is especially useful for when this is not a whole number, like a fraction or a decimal or something gross. Okay, so first off, you can hit second table, and you can see, you can hit like ups and downs, and you can find that if x is 4, our y value is 24. Okay. That's a fast way to do that if this is a whole number. If this, however, is a decimal, like 1.4, so let's do that, f of 1.4, we're going to go back to our graph, and we're going to hit this second key and then trace. See how it says calc above it? That opens up this calculate menu, so second and then calc. This helps us find values, which is y values, zeros, mins and maxes, not calculus style, but it helps you find the x and y values of those mins and maxes. We're going to find a minimum. Helps you find intersections if you have two lines, which we will end up doing. It also helps you figure out slopes of tangent lines at certain x values. This is a little gross and tricky because I'll have to mess around with this a little bit. I haven't actually done that a lot, like from the graph and from this calculate menu. So we'll kind of mess around if we've got time. Okay, so I am wanting to find a y value, right? F of 1.4 is finding a y value. So I can either hit 1, or since I am highlighted on it, I can hit enter. So I'm finding f of 1.4. Down here, it says x equals, and then it's got this little cursor here. I'm going to click 1.4. and then it shows up as the x value. I hit enter, and it does two things. It jumps the cursor to this spot right here, the little x, which is at x equals 1.4, and it jumps it down to actually on the curve at the correct y value, which is negative 7.616. And of course, there's other decimals and stuff that go on after it, potentially. I don't know. Well, maybe. So that's how to find a y value. Let's double check that it actually works by doing second, calc, and then we'll hit 1 or enter. And let's go ahead and do 4, and we should get 24. So 4, enter, 24 for the y value. Okay, so it's like way the heck up there. Next thing, let's find some zeros. We've got -2, 0, and 3. That should be it. We're just going to find one of those just so we can practice it. I will hit second and then calc to get back into this. Number 2 is 0. So I hit enter. What? Oh my gosh, I hit 2, Miss Campbell. Hitting enter again, if you've got something down here, will just clear it all out and it goes away. Second, calc, we want 2, which is 0. There we go. So I hit 2. The calculator will ask you 3 questions, starting with left bound. So currently, my x value is at 4.04, which is somewhere, here's 1, 2, 3. So 4.04 is somewhere here and way up there. If we want to figure out what this 0 is, I need to move my cursor left, and it will trace along this curve. And we need it to be really less than 3. But I'm going to hit left a few times, and we can see it bouncing down here. It looks like it's to the left of that point, but I'm just going to hit left one more time for safety. Okay, so this point is at an x value that is to the left of this x value. We want to be to the left, so I hit enter. Then it asks for right bound. So I hit right a few times to get the cursor to pass over that, that 0 over the x-axis and go to the right. I hit enter again. The last and third question is the guess. Now, your guess only matters if you have your cursor close to 2 different zeros, and both of those zeros are in between your left boundary and your right boundary. So your guess really doesn't matter, so you can just hit enter one more time. So you have to be to the left for the left bound, right for the right bound, and then just hit enter a third time, and it gives us the point 3, 0 and tells us it is a 0. That's this one. You can practice that for this one and this one. Pause the video and do that if you want. Okay, next thing we do is find a minimum. I hit second and then that calc again to get to minimum, which is number 3. You can hit down, down, enter, or just 3. Okay, we need a minimum. There is a maximum here and a minimum here. This finds relative maxes and mins because there is no absolute max or min on this. This goes up forever and this goes down forever over here. So we want this minimum right here. It asks the exact same 3 questions as when we found the 0. We need to be to the left of that 0, so I hit the left key. The up and down key does not do anything if there's only one curve on here. All right, so left bound, I am to the left of that point. So hit enter, then it says right bound, hit right a few times until you are for sure to the right of it. Hit enter, and then our guess, just like with the 0, it doesn't matter as long as you only have one minimum in between that boundary. And see those arrows, so that's on the left and that's on the right, and that point is between them. Hit enter that third time, and we get the minimum, which is at 1.786, negative 8.209. Fabulous. Trying to think of a way to make the calculator do this next thing that I wanted, and I'm not sure I'll be able to do it. Okay, if your calculator says like x equals 2.867 e negative 7 or 75 or something, I don't know. If this e negative thing has happened, what this is x equals 2.867 times 10 to the negative 78th power. That's scientific notation that says that this number is so small, the answer really should have been 0. Okay, so if you see e and then a negative given to you on one of these guys, it should have been 0. Your calculator's just doing like its special program, and it gets you a number that has been rounded awkwardly. Okay, so this 78 means the decimal has been moved over 78 times. Okay, literally if it's just e negative anything, it's supposed to be 0, just so you know. Okay, that happens on the mins and maxes, and especially like these zeros and whatever, sometimes it happens. Okay, intersect is the next thing I want to talk about because that is number 5 on our calc list. Okay, so if we need to find the intersection between two functions of any sort, we need a second function. So I hit y equals, and I'm gonna make that y2 show up again. So I'll hit down, left, enter, and now both of those equals say that both of the y values will show up. Or sorry, both of the functions will show up. And if you hit graph, there's that second function drawn. It is that straight line we expected. Now, these two functions do intersect. They intersect 1, 2, 3 times. So we could spend the time finding all 3 intersections. We're just gonna find one of them. If you're doing like a calculus problem where you have to find areas, you would need to find this one and this one where f of x is above g of x, and then you'd have to use this one for a and b, where g of x is above f of x. So you'd have to do like f minus g for the first one, and then g minus f for your second integral. Okay. We are finding an intersection. Okay, so I'll hit second, calc, and then number 5 is intersect, so hit 5. It asks you a different type of question this time, first curve. So we can see, I'm gonna move this around so we can kind of see the cursor is currently on my y1, which we can see it up here, y1 equals, and then that's the equation that it's on. I hit enter anywhere on that. It just needs to select somewhere on that curve. Then after you hit enter, the cursor bounces over to your second curve automatically. It does that. So you don't have to figure out how to do that. So second curve, you select it, and then your guess. Well, the cursor is currently very, very close to this point. So if I hit enter to like lock in this guess right now, it will give me this point of intersection. If that's not the one I want, I just have to hit right a few times to get my cursor closer to the other intersection, or right even further, and that gets me close to this intersection. Okay, so you don't have to move your first and second curve buttons around. You just need the guess to be close to the right spot. I'm gonna hit enter. It's gonna give me this one, which it actually intersects at the point 3, 0. 3, 0. Okay, these guys are probably decimals and kind of negative or whatever. We could, if we wanted to, say this y equals x minus 3. We could plug in the x minus 3 here, and we could like multiply this all out and combine like terms and get it to equal 0 and solve for the 3x values that would make both of these equations true. So we've got this system of equations I said earlier. So we just found one of the solutions for our system of equations. It's 3, 0. Okay. That is particularly useful for like some ACT problems. Okay, finding some points of intersection. Of course, on the ACT problem, it's multiple choice, so you could just plug in the x and y value in here and see if it works, and plug it into this one too and see if it works there. So you can kind of finagle it on there. Okay, what else do I want to show you? Window. Okay, the window right here has a few options. I've clicked window. Now, our graph, we can see every important part because we know this is a cubic function and we know that's linear. So these are our 3 points of intersection. But what if we wanted to see them closer? Okay, because all of this up here, nothing's really happening in this area. Nothing's really happening over here or down here or over here. So really, if we started at the x value of negative 1, 2, 3, like negative 4, we would see everything that we needed. And if we stopped at the x value of 1, 2, 3, 4, we would see everything we needed. So it would like cover up all of that and only focus on this piece. And then we could stop here and stop here. Hopefully I'm not making the screen too dark with my fingers. Okay, so we would still be able to see our mins and maxes. Okay, that is especially valuable if this was taller, like very, very tall, so taller than y equals 10 and lower than y equals negative 10, very wide, or maybe it's very short and you want to like zoom in more. Okay, hitting zoom and then hitting zoom in is really not the best way to do it. It zooms you in like towards a specific x and y point, and it's kind of hard to control. Great, that zoomed us in close to that point of intersection. Like, who cares? We can't see our cubic function, and we can't see the other 2 points of intersection. But we can see this 0 pretty darn well. Great. Okay, so I feel like I've kind of ruined our graph here. I'm kind of glad that I ruined it because I can show you something. If you hit zoom and then you hit the 6 button, see that Z standard? Z standard is the standard zoom, right? It gets you back to your classic graph screen, okay? Currently, if you look at the window, our minimum X value it shows is negative 0.7 and our maximum is positive 5.7. The X scale, meaning where your tick marks, is only by ones. Your Y minimum, so your lowest and highest Y values, and then your Y scale also has ticks by 1. It's not a good setup for us. So I'm going to hit zoom, and then I'm going to hit that 6 to get standard. And it brings us back to our normal screen. So zoom 6 is pretty useful because it cleans it up for us a little bit better. Another useful zoom is zoom, and then if you hit up, oh, okay, maybe I had an old calculator when I used to do this all the time. Zoom 0 is zoom fit. Mine didn't have this A, B, C, D and such. So zoom 0 is zoom fit. Sometimes it's useful and sometimes it's not. This doesn't really look very good to us. So I'm gonna go back to my zoom 6. Sometimes it'll make it so that your calculator shows only the most important information. Sometimes you get gross stuff like what we just got. Okay, I'm gonna hit window, and this might be the last thing we get to do. The X minimum, the lowest X value that we really need is negative 4. Okay, honestly, the lowest one we need is probably negative 3, right? But to find that other point of intersection, but I give mine a little bit extra room. My X maximum, I'm gonna use that positive 4 because we know our functions intersect at 3, 0, and then there weren't any mins or maxes or anything interesting to the right. My Y minimum, let's do a negative 8 and see if that's good. And then Y maximum, let's do a positive 8. Okay, you can always go back and change it if it's not pretty, like if you can't see everything that you need. Oh, and look, we can't really see that minimum very well. So maybe I should have made my Y minimum like negative 12 or something. Let's do that. So Y minimum, oh, I just messed that one up, negative 4. I hit clear for some stupid reason. Okay, negative 12. And I hit graph. And there we go. We don't have all that extra wasted space. And it's easier to see this minimum than it was before because it was a little bit low before at that negative 8.2. Oh, duh, our minimum's negative 8.2. I should have known that my window wouldn't have worked for that. Oh, well. Okay, other things. So we just did window. And of course, if you hit if you hit zoom 6, it'll change your windows back to negative 10 and positive 10 for your X and Ys. I'm going to hit second calc, and I'm going to take a look at that number 6, that dy dx. I'm currently on my first curve. If I hit down, that takes me onto my second curve, and you can see which one you're on up here. Let's find the slope of this first curve. Now, if we're smart, we can notice that the derivative of x minus 3 is just 1, so our derivative should be 1. Okay, I'm going to hit enter. It gives me the, well, here we go. The dy dx is 1 at that point. Technically, it's 1 on this entire line, right? Okay, let's do another one on the other graph. So second calc, and then we're doing 6 for the dy dx. I'm on y1 this time, and it is this point. I'm curious if I can pick a specific x value. X equals 2. There it is. Okay, so you can pick your x value, and it gives you your dy dx, which is your slope. Okay, so you can either use left and right arrow keys to just kind of move around and kind of compare, like, are my slopes getting higher or lower? Or you can type in a specific x value, hit enter, and it gives you your slope. Okay. Cool. It doesn't give you your y value if you do that, though. You'll have to hit second calc 1 to get the y value. No big deal, though. This is probably one of those scientific notation issues. It's probably actually literally just 2. What else? Second calc, 7. We're going to do an integral this time. Let's do lower limit. Let's do the lower limit as 2. Enter, and the upper limit as 4. Oh, that's not going to fit on our graph well. Let's do 3. So I'm only doing y1, and I'm doing a equals 2 and b equals 3. And we can see that we have shaded in this little region right here. So it did not care about this other line, like my second y equals equation. So it found the area between my f of x function and my x-axis. And that integral is negative 5.08. This decimal is significant enough, like it's a large enough number that it hasn't been like a scientific notation issue. Obviously, on a calculus test, you would need to show like what you set up, like what functions you set up in order to prove that you are actually doing things correctly and setting them up correctly. But it's kind of nice to see that. Notice that it's negative and our shading is below the x-axis. Okay, I would assume that if I had plugged in the 3 for A, the lower the limit, and 2 as B, the upper limit, since that's backwards, this probably would have been a positive 5.08. I would assume so. All right, I've got a meeting, so I'm going to stop the video here, and I will save it to you when I can. Send it to you when I can.